A dozen steel rollers crack one wheat kernel into flour in minutes. But here's the twist, the mill never actually crushes it. It shaves the kernel open, one gentle pass at a time. Why not just smash it? Pulverize a whole kernel in one blow, and you get gritty, gray wholemeal bran flecks and all. The mill's real job isn't grinding. It's separation. First, it must split the starchy white interior away from the outer skin and the oily seed. Then grind only the interior. Get that order wrong and every batch is ruined. Start with the seed itself. A wheat kernel has 3 parts. The outer skin, called bran, is the tough brown wrapper, about 14% of the kernel. The germ is the tiny embryo, the part that would sprout roughly 3%. And the big starchy middle, the endosperm, is the other 83%. That endosperm is the prize. It's what becomes white flour. The bran and germ carry oils and fiber that turn flour bitter and cut its shelf life. So for white flour they have to go. See the problem? These 3 parts aren't in separate piles. They're fused into one hard little seed. That single fact, 3 ingredients baked into one kernel, is why milling is a separation problem long before it's a grinding one. But you can't peel a kernel that's dry and brittle. It just shatters. So before any roller touches it, the wheat gets prepped. Here's the first step. Raw grain pours over vibrating screens that catch stones and straw. Magnets pull out stray metal. Air currents blow off dust and light chaff. Now it's clean but still too brittle. So the mill adds water, raising the grain's moisture to about 15 to 16%. Then it waits. This resting stage is called tempering, and it runs anywhere from 8 to 24 hours. During that rest, the tough bran skin absorbs water and turns leathery, while the endosperm inside softens. Why does that matter? Because leathery bran peels off in clean flakes, instead of shattering into 1,000 specks that would fleck your flour brown. Now the tempered kernel meets the rollers, and this is where the shaving begins. The first stage is the brake system. Picture 2 grooved steel rollers, their surfaces cut with sharp corrugations spinning toward each other. Here's the clever part, they don't spin at the same speed. One turns faster than the other, so their grooves don't press. They scissor past each other. That shearing motion cracks the kernel open along its seam instead of crushing it flat. And there isn't just one pair. A brake system has 4 or 5 pairs in a row, each set a hair closer than the last. The first pair barely nicks the kernel open. The next scrapes a little endosperm off the bran. Each pass strips a bit more starchy interior away while leaving the bran in broad flakes. By the last brake pair, the endosperm chunks are mostly freed, and the bran is nearly bare. But cracked grain is a jumble of sizes. How does the mill know what to do with each piece? The answer is sifting, and it happens after every single roller pass. The sorting machine is called a plant sifter, and it's a tall stack of mesh screens that shakes in fast little circles. Think of it as a nested set of sieves, coarsest on top, finest at the bottom. Cracked grain pours in and the shaking sorts it purely by size. The big bran flakes are too wide to fall through, so they stay on top. Medium endosperm chunks, the millers call these middlings or semolina, drop to the middle screens. And the finest particles, already flour, fall all the way through. Now each pile goes somewhere different. Bran flakes route back to the next brake roller to scrape off any clinging endosperm. Middlings head toward a different set of rollers entirely. Flour is collected. This sort and route loop, repeated after every pass, is the real secret. It's why a flour mill is a whole connected system, not one big machine. Follow the middlings because those coarse endosperm bits still aren't flour. They go to the second roller stage, the reduction system. These rollers look different. They're smooth, not grooved, and set extremely close together. Where brake rollers sheared, these ones gently grind. A pair of smooth rollers squeezes the middlings, crushing each coarse grain of semolina a little finer. Then you guessed it, the result is sifted again. Whatever isn't fine enough goes to the next reduction pair, which sits even closer and grinds it finer still. Pass after pass, the coarse semolina is stepped down into fine white powder. And here's where the title's number comes from. Add up the 4 or 5 brake roller pairs and the several smooth reduction pairs, and a working mill runs around 12 rollers in sequence. Not one giant crusher, a dozen small stations, each doing one tiny step of the reduction. So trace one kernel the whole way through. It's cleaned, watered, and rested until the bran turns leathery. It's cracked open across 4 or 5 brake rollers, each shearing pass freeing more of the white interior. After every pass, a plant sifter sorts the pieces by size and sends each one exactly where it belongs. The freed endosperm rides through the smooth reduction rollers, ground finer and finer, sifted between each pass, until it's fine white flour. The bran and germ are streamed off the whole time. That's why the gradual design wins. Grinding a little and sorting a lot gets you the most white flour, a consistent fineness, and no brown flecks. 3 things one crushing blow could never deliver. The minutes-long trip is really dozens of tiny crush and sort steps stacked end to end. So the whole trick is order. Separate first, then grind gradually, and check your work by sifting at every stage. But now you've got the mill sitting on separate streams, pure white flour, brown bran, oily germ. So how do those become bread flour versus soft cake flour on the shelf? That's blending, and it's a story of its own. We'll open that box next.